Continuing our series on vintage pieces of test equipment, this is a Precision Model E200C RF signal generator. This was a very popular service grade generator and was made from around 1940 up until the 1960s in some form or another. They underwent some cosmetic changes as well as some circuit changes, but the basic concept was still the same. Sometime in the mid-60s, B&K bought out Precision, and shortly thereafter they introduced the Model E200D signal generator that was a solid-state version of this one, although it looked a lot different, but there again the concept is still the same. I believe this model was made in 1949 according to some date codes that I found, but I could be wrong about that. Here are RF output jacks and our RF level controls here. And here's our band selector switch to select which tuning band that you're on. Here's our modulation control, which essentially varies the degree of audio modulation. This is a power supply here, 0 to 50 volts, and its main purpose was so that the service technician could cut the AVC line inside of a radio under alignment and use this AVC voltage here, which is variable from 0 to 50 volts, to substitute for the set's AVC voltage. Now, Precision claimed that this made alignment more accurate, but I'm really not sold on the idea. I think that was just a marketing gimmick to sort of give Precision a lead on the rest of the competition that was out there. And here's our selector switch. We have unmodulated RF output, which means simply an RF carrier with no audio signal riding on it. Modulated RF output. External modulation, that's where you can feed an external audio source into the signal generator, and that audio source will ride on the RF carrier. And 400 cycle audio, which is available at these jacks right here. The purpose for that is basically just to have a test tone to test the audio section in a radio. This generator has an output frequency coverage from around 80 kilocycles up to around 30 megacycles on fundamental frequencies, and from there up to 120 megacycles on harmonics. Here's the inside of the generator. As you can see, it's a 3-tube unit. We have a 6SJ7 here for the RF oscillator, and of course this is the RF assembly that contains the coils necessary to produce an RF frequency. And these are your trimmer capacitors. Their purpose is for calibrating each band so that the frequency output of the generator matches what's read on the front control dial here. And here's our variable tuning capacitor. When used in conjunction with these coils, you get the proper RF output frequency. And here's our audio oscillator or modulator tube, which is a 6C5. Here's our rectifier tube, which is a 5Y3. I think earlier versions of this generator used a Type 80 rectifier tube. And as you can see, I've replaced the capacitors. There are a couple of capacitors that I replaced on the RF assembly, as well as under the chassis here. These blue disc capacitors are the AC line bypass caps that connect from one side of the AC line to ground. It's really important that you use AC safety capacitors in this application. The originals were 0.01 microfarad, which I didn't have, so I had to place two 0.0047 microfarad caps in parallel to get me close to the right value. And there was one resistor here that was up in value, so I didn't have the exact value, so I used two resistors in series to get me close. Okay, let's fire this up and run the smoke test and see if it operates. And I did, of course, replace the original power cord. Okay, we're at our null point, and our calibration is just a slight bit off, which is no surprise. There's our null point.
I'm going to take off my jacket.
And we're just a little bit off, but more concerning, it appears that our internal modulation is not working very well. As you can hear, it's just barely coming through, so I think we need to investigate that area of the circuit. Okay, back on the Precision E200C signal generator. I'm trying to figure out what's wrong with the audio oscillator circuit. It's basically non-existent when viewed on a scope. Turn the light off where we can see it. This is what we're getting. And we're set to 0.2 volts per division. So yeah, that's a very small signal coming out of the signal generator. Now I'll hook up another signal generator and show you what it's supposed to look like. And here we are with the audio oscillator portion of another signal generator connected. And this is what we're now getting. Well, my scope is having a little bit of an issue here, but this looks more like what it's supposed to look like. We're now set on 2 volts per division, so this other signal generator is outputting a much stouter, cleaner waveform than what the Precision signal generator is kicking out. And unfortunately, this is one of those situations where I've checked everything I know to check and can't find any reason for the problem. The audio oscillator section is obviously misbehaving, and I've replaced the original paper capacitors with the correct value capacitors in a more modern form, obviously. The only resistor that was bad was this 250 k ohm resistor, which was originally a carbon composition resistor, and I replaced it with a film type resistor. I don't know if that might have any effect on it or not, but that's the only other thing I know to try. All the voltages seem correct. I've substituted a new tube. I've checked the switches and controls. Nothing checks out of place, so why is the dadgum audio oscillator not behaving right? I've checked the modulation transformer. Its windings appear to be good, although I suppose there could be a shorted turn or two causing a problem that's not showing up on the ohm meter. But I think for right now, since I'm just drawing at straws here, I'm going to replace this resistor with a carbon composition type, if I can locate one in my stash, and see if it makes a difference. Okay, I've now switched back to the original carbon composition style resistor, and we'll now give it another test run and see if the condition improves any. Okay, it seems that replacing those resistors with the original carbon composition type helped tremendously. As you can hear, we're getting modulation now that we were not getting before. And now we'll take a look at it on the scope. Although weaker than the other signal generator, we're on the 2 volt per division range, and even though it is weaker than the other signal generator, it's stronger than it was before. And our waveform does look a little wonky. I'm going to try this new tube again and see if that makes any difference. Tapping on the old tube, it's obviously microphonic, and you can see the waveform on the oscilloscope going bonkers. So let's try another tube and see what happens. Okay, installing another tube didn't help the situation any, so we'll go back to the original tube. And this may be as good as it gets here. Now, we do have some sort of usable modulation that we didn't have before. So, like I said, that may be as good as it's going to get. Okay, here we are looking at the unmodulated RF output. Now we have the modulation turned on. As you can see, there's something there now. But it's still not quite as strong as I think it ought to be. Okay, I think we're going to give this a rest for tonight while I sleep on what I might need to do next to this. If anyone has any ideas, I'd love to hear from you. Our objective is to get this audio oscillator working a little bit better. Okay, there you go, my Precision E200C signal generator. Thanks for watching, and part 2 should be coming up shortly. Here's a Philco radio from about 1953 or so in a wooden cabinet. This has the standard broadcast band and what Philco referred to as the public service band. It's really not much on it anymore. The public service band runs from roughly 1.7 megacycles to 3.4 megacycles, but like I said, not much on it anymore. I don't know what the deal is with this radio. It was just brought to me, and they'd like to get it playing again, so let's see if we can make that happen. Here's our chassis removed from the cabinet. This is a 6-tube chassis with a 3-gang variable tuning capacitor, which means this set has a tuned RF stage, which means it should be a good performer once it's working properly. Here's the underside of the chassis. It doesn't look like it's been monkeyed with too much. Here's our loop antenna and our speaker inside the cabinet. Now, on these particular radios, the antenna and speaker are soldered in place. You can't just simply unplug them, so to make things easier, I just unsoldered the antenna and the speaker, and for testing we'll use alligator clip leads to make the necessary connections. And then whenever I'm finished, I'll resolder everything once I put the chassis back in the cabinet. Okay, let's get a baseline on this and see what we have to work with. I have the antenna and speaker clipped into place. I have the radio plugged into the variable AC power supply. We'll bring it up slowly and see what we get. Now, one thing I noticed is this 35W4 rectifier tube has gone to air, and you can see it's cracked along the base. So either this tube was subjected to a pretty good physical shock to crack it, or there was a major short which caused this tube to get unusually hot and caused the glass to crack. Let's see if we can find out which. Okay, before I replace the tube, I'm going to go ahead and replace this 3-section electrolytic filter capacitor. It's a Philco branded part and looks very original to the radio. It's a 40 microfarad, 30 microfarad, and a 30 microfarad. It's a 3-section We just replace those with individual capacitors. And I'll also replace these paper capacitors just for maximum reliability. Okay, I have most of the capacitors replaced, and looking at this closer, I think I might have found out what caused the 35W4 rectifier tube to self-destruct. If you'll notice here, here's a bumble bomb capacitor that's blown apart. One side connects to circuit ground. The other end connects to pin 4 of the rectifier tube, which is the filament. So if that capacitor were to short, then I could very well see it causing the rectifier tube to blow up. So we'll go ahead and replace that capacitor, install a new 35W4, and then fire it up and hope for the best. Here's a better view of the exploded bumble bomb. As you can see, it's just a paper capacitor inside of a plastic case. These came out in the 1940s and were used up until probably the mid-60s or so. They were supposed to be an improvement over the old wax paper capacitors of the 30s and early 40s, but actually they were a deprovement. They weren't an improvement, because it seems like every one of these I find are either blown apart, or when you test them for leakage, they test much worse than an old wax-covered paper capacitor from the 30s.
Over the last week or two.
Okay, well that sounds more like what a radio is supposed to sound like.
It should be feeling a little bit optimistic, because guys are starting to send signals that they may wind up fixing indicators, and that's not just...
Household cost for health care is up $3,000 to $4,000.
Yes.
On food.
Sacrifice for your work.
There's a weak station coming in, so that tells me that the front end is working pretty good. Okay, what I'm going to do now is just let this radio play for a while and make sure we don't have any silver migration issues with these IF transformers. Hopefully we don't. If we don't have any issues with those, then we'll perform a few other steps to try to make this radio play just a little bit better, and then we'll button it up and it'll be ready to go back home. Well, we've been playing for about 2.5 hours now, and no thunderstorm effect, so that means the IF transformer should be okay. Last thing I'm going to do is check the voltages on the audio output tube and the audio driver tube and make sure they're what they should be. I think we should probably be getting maybe a tad bit more volume out of this set. And then if all that checks out, then I'll put it back together and it'll be ready to go home. Okay, checking our voltages on the 35C5, and yes, I was using the socket test adapter for that. Makes it a little easier. Our B plus and our plate voltage and screen voltages were running around 110, 115. That's not too bad, maybe a little high. Our cathode voltage is running around 5 volts. That might be a little low. I'm used to seeing about 9 or 10 volts on the cathode on these tubes. And when I check the tube on the tube tester, it is showing a little bit weak. And you can see I'm having to hold the tube in position with one hand or one finger and press the button with the other finger, because the socket in this tube tester is worn out and needs to be replaced. I guess I'll get around to that one of these years. Alright, let's go find another 35C5 and see if our situation improves any. Well, this 35C5 is much stronger. Let's put it in the radio and see how it performs.
Very good reporting, and then
okay, our voltages are reading about the same. Our audio sounds a little cleaner now, so I'll go ahead and leave this tube in there since it tests stronger than the one that was originally in there. Okay, looking at the plate voltage on the 12AV6 driver tube, we're running about 37 volts. That may be a little low, and that's most likely caused by a resistor that's gone up in value. Okay, this particular radio contains a device called a couplet that contains several components inside of this little package here. This particular couplet contains the plate load resistor for the 12AV6, the coupling capacitor that couples the plate of the 12AV6 to the control grid of the 35C5, and it also has the grid bias resistor, typically 470k ohm, that connects between the control grid of the 35C5 output tube and ground. Typically this is a 470k ohm resistor on the control grid to ground. We're reading about 500 and we'll round it up to a nice figure, 590k ohms, so that's a little high. And I'll have to pull a schematic to see what our plate load resistor on the 12AV6 is. Typically it's in the 330k to 470k ohm range. Well, we're reading about 650k, so that could explain our low B plus voltage. Now, of course, these couplets are no longer available, but don't worry. It's no problem to recreate one using conventional components.
But it's dangerous.
Okay, I peeked at the schematic for this set, and it seems that our voltages are about what they're supposed to be, and the resistors inside of that couplet are marked to be a little bit lower than what I'm measuring. So, since our voltages are within tolerance, I'm not going to worry about doing anything to that couplet. It's just fine. All I'm going to do at this point is touch up the alignment, and I probably won't even use a signal generator for that because it's really not that bad off. And then we'll call it done. And here we are on our weak 670 station, and it's coming in pretty good. So if that station's coming in, then I'd say this radio is working pretty good.
That the United States ought to have. The president goes golfing.
Austin, Georgia, Lowndes High School line.
All night long.
So I think we can put this radio back in the cabinet and send it back home to its owner. Hey, here it is back together.
Now, they are together now. They're neighbors now, even though they don't want to be.
I think that station's about 90 miles away.
At Quality PC, we know that the most important computer we will ever work on is yours.
The Quran specifically speaks about infidels.
There's 670.
Being preached by some imams, many imams as a matter of fact, is a call to war.
Well, I'm sorry.
Have you...
Now, show you one thing I had to do. For some reason, when I put this set back together, it started squealing and howling and motorboating on the upper end of the AM broadcast band from about 1200 on up. Well, I could touch the antenna lead inside of the radio and it would behave perfectly. I could also clip a clip lead onto the antenna lead inside of the radio, and it would play perfectly. Situating wires around didn't really help the problem outside of the cabinet with the antenna connected with alligator clip leads. It worked fine, as you heard earlier. So what I did, I just attached a clip lead, soldered of course, to the antenna terminal inside of the radio, and the motor boating and squealing went away. And if the owner happens to be in a poor signal area, he can clip a long wire outside antenna to this, give him a little bit better reception. But okay, that's about all I've got for this 1953 Philco. It works pretty good now. And our root problem was a bumble bomb capacitor that shorted and took the rectifier tube out. And then of course all of the other old paper and electrolytic capacitors were bad and leaky, and we had a bad weak 35 C5 output tube. So I think it's good to go for a little while longer. A few more years, a few more decades. It might outlive all of us. Okay, thanks for watching, and more to come later.